All right, so this is section 1.2, problem 9. We have a polynomial of degree 5. Okay, so that means like x to the 5th with other stuff. Has leading coefficient 1, has roots of multiplicity. So the root means that, if it has a root of x equals 1, that means it has a factor of x minus 1. And multiplicity means that it just has more than one of those. Okay. So the roots of multiplicity at x equals 1 and x equals 0, and a root of multiplicity 1 at x equals negative 4. Okay, so typically, when I think of a polynomial of degree 5, I would write that as like something times x to the 5th plus something else times x to the 4th, and then, going on down the list. Right? Okay, but we're going to write this a different way, because if I write it this way, I've got all these 6 unknowns, and it's, really hard for me to figure out what's going on. However, what I can do is instead I can start off by writing this thing in factored form. So it has a leading coefficient of 1. So if I FOIL everything out, the x to the 5th is going to be a 1. And I know it has this, x equals 1 is a root, so x minus 1 is a factor. It's of multiplicity 2, so I have 2 of those. Okay. X equals 0, so this is like an x minus 0, or typically we'll just write that as like an x. That's also multiplicity 2. And then x equals negative 4. So x minus a negative 4 is the same as x plus 4. So this is what the polynomial looks like in factored form. And because it has a leading coefficient of 1, that's it. Then we're good to go with just that. If you really wanted to, you could FOIL it out, but this just says find a possible formula, and this is a possible formula. So I'm just going to go with that. Does that make sense?
Yes, thank you.
All right, so let's go ahead and look at, this is section 1.2. This is one is problem 10. Write an equation for the degree 4 polynomial graphed below. Okay, so it's telling us that it's degree 4. That's a useful piece of information that we don't necessarily know from the graph, right? And what I'm going to do is I'm going to write out this polynomial the same way that I did the last one. I'm going to write it in factored form instead of like an x to the 4th, x third, right, and so on form. And so what I can do is I can see that it crosses the x-axis at x equals negative 4, so I know that x minus negative 4 or x plus 4 is a factor. That also happens at negative 1, so x minus 1, x minus negative 1 or x plus 1 is a factor. Now, this one is interesting, and, depending on the pre-calculus class, this might have slipped by you, but here the graph hits x at x equals 2, it hits the axis, so it has an output of 0, but it doesn't go through, it bounces off. And just to give you a frame of reference, if I look at y equals x, I know that has a 0 at x equals 0, right, of multiplicity 1. If I look at y equals x squared, that has a root at 0 of multiplicity 2. If I look at y equals x cubed, that has a root at x equals 0 of multiplicity 3. And let's draw one more, x to the 4th. It looks kind of like the x squared, but it's a little steeper. Okay, the even powers hit and bounce off, right? The odd powers go through. So when this one hits and bounces off, I know that it's an even multiplicity. Since this is degree 4 and 2 of them already accounted for, it's stuck at just being 2. So I know that x minus 2 is a factor, and I'm going to have that twice. Okay, now the difference between this problem and the one before it is I don't know what the leading coefficient is. So I'm just going to put some unknown constant out in front. Maybe I'll just write it as like an a. All right, so I need an extra piece of information to solve for what the a is. And I've already used, this point, and this point. The fact that they're roots has played into me writing out part of this equation. I'm just going to pick another point off the graph, and that's going to be the y-intercept. So when I plug in 0 for x, I know that y is -1. Okay, so what does that look like? Well, that means that when I plug in 0 for x, my output is -1. And when I plug in 0 for x, I'm going to get 0 plus 4, 0 plus 1, and then 0 minus 2 squared. So -1 equals a times 4 times 1 times 4. So -1 is 16a, so a is -1/16. So then that tells me that my equation is going to look like -1/16 x plus 4, x plus 1, x minus 2 squared. Okay.
Got it.
You know, and just like the last problem, if you were required to, you could FOIL all of this out, but there's nothing in the problem that says that I'm required to write it in one way over another, so I'm just going to leave it like that.
Okay.
Okay, any other problems that you wanted to take a look at?
Yeah, can we go ahead, skip a few questions and talk about the piecewise functions?
Yeah.
Like question 19 or 20.
Okay, so here's 19. We can go through both of them. Complete the equation for the piecewise function graphed below. So the key with a piecewise function is to remember what it's doing is breaking up the domain, and it just has different formulas on those different pieces of its domain. Okay, so when x is between -6 and -3, oops, let me see if I can highlight that. Okay, so this piece of the graph over here it is on this piece of the domain. When x is between -3 and +1, right? I'm going to have a different formula. And then for x is bigger than 1, which is this piece of the graph, I'm going to have this formula. So what I'm going to do is on each of these separate pieces, I'm going to find a formula that gives me that graph. So these are all lines, so I'm going to be finding equations of lines. Okay, so for the green one, what I'm going to do is I'm going to say, well, to find equation of a line, if I have 2 points, that's a good way to go. So I'm going to read 2 points off the graph. So here I have -6, and it looks like 3.5. And for my second point, we have -3, 5. Okay, to find equation of a line, I start with the slope formula. So I'll look at the difference in y's over the difference in x's. So 5 minus 3.5 is 1.5. -3 minus a -6 will give me a +3. Okay. There are different ways to do this. Once you get decimals, if you wanted to, you could just divide this on your calculator and that'd be fine. I would look at this and say, well, I can get rid of my decimals by multiplying the top and bottom by 2, and then 3/6 is 1/2. But if you did that on your calculator and you got 0.5, you'll be in the same spot. So there's our slope, and then I can pick either of the points. I'm going to pick the one that doesn't have the decimal in it. So y minus 5 equals my slope times x minus -3. So y minus 5 is 1/2 x plus 3. Y minus 5 is 1/2 x plus 3/2. Fractions came back. And then when I add 5 to both sides, 5 is like 10/2 plus 3/2 is 13/2. So that gives me an equation for the green part. Okay, the purple part is a horizontal line. No matter what my change in x is, the change in y is always 0. So the slope is 0. Okay, and the y value is always just 4. So on this piece of the domain, the output of the function is always just 4. Right, or the equation of that line would be y equals 4, but I can just write in 4 for my formula. Okay, so that part was easy. For this last part, I need to find 2 points. I can use this open circle as a point, even if it's not technically in my domain because 1 is not allowed. But it's still, it runs into it, right? So that's still going to be a, if without cutting down my domain, that's still going to be a point on the line. So that I have the point 1, 3. And I just need to find another point that looks like I have nice integer coordinates. This one looks good, 3, -2. Okay. Then I go through the same process. Find the slope. So change in y. So I'll do 3 minus -2 over 1 minus 3. So I subtracted differently this time. For the first one I did second point minus the first point. This one I'm doing the first point minus the second point. It doesn't make a difference. So I get -5/2 as my slope. So then using my first point, y minus 3 is -5/2 x minus 1. Y minus 3 is -5/2 x plus 5/2, and then add 3 to both sides. 3 is 6/2 plus 5/2 is 11/2. Okay. Does that make sense?
Yeah.
All right. I feel like I went through that a little bit quickly. So feel free to slow me down as I'm going through these.
No, that's all right. It just seems like it's 3 separate equations of a line, which it is, right?
Yeah. Yep. It's the domain that breaks it up.
Yep. Okay. Thank you.
All right. Well, let's go ahead and take a look at problem 20 then. I think that's basically the same idea. Right? So we just grab 2 points and then run through the process, find the slope, write down the equation for each one. And the horizontal line bit is nice and easy. Should we go through this one?
No, I think I got it.
Okay.
That's all the questions I had for now.
Okay.
Yeah, I think that's all I got.
All right. Sounds good.
All right. Thank you, Professor.
Sure. See ya.